In this problem, we are given an array or list of numbers. Some will be positive, some will be negative, even 0 can be there. So you have to find the first missing positive number, and that means the smallest positive number that can be put there. So let's look at an example and it will be clear. So let's say we have this. So its size is 3. So we have 0 here. 0 does not count whether it exists or not. So for smallest positive number will be 1. Next is 2. So 1 is present, 2 is also present, 3 is not present. So this is the smallest that we can get. So we return 3. Here again we will check for 1. 1 is there, 2 is not there. So here we will return 2. Here 1 is not there. So we will return 1. So what should be our approach? We are asked to do it in O of n, where n is the number of elements in the list. So this is the requirement of the problem. And another requirement is that space should be O of 1. These two requirements should be satisfied. If these requirements are not there, you could have easily sorted them. So these are not in sorted order. You can sort them and then find where is 1. Or if 1 is not there, then you will return 1. If 1 is there, then you will, if it's sorted, you can just traverse it left to right. And the first place you find a missing value, you return that. So that would be n log n, but we are not allowed to do that. It should be O of n. Another thing is that if this second constraint was not there, so this is time, this is space. So let's say space constraint was not there. So what you would do, first thing, how you can find the missing number. So there is one case. First case is that 1 is not there. So 1 is missing. So we will search in this list because 1 is the smallest positive number, followed by 2, 3, 4 and so on. So 1 is not there, then return 1. This is easy case. Searching can be done in O of n, even if it's not sorted. If it's sorted, log n, but O n is good for us. Another case is that 1 is present. So this is -1, this is +1. So this case is the main case that we need to handle. Now think, let's say we have an array of size 5. So one thing can be that we have all the numbers from 1 to 5. So 1 is there, 2 is there, 3 is there, 4 is there, 5 is there. Then we will return 6. But if all of these are not present, some other value is present, like we have 3, 2, 1, -1, 6, like this. So we have 5 spots and we don't have all of these numbers 1, 2, 3, 4, 5. So we have only 5 spots. So other number can only come when one of these are not present. Then only we can put some other number there because the slot is fixed. As in this case, what are missing here? We have 4 and 5 are missing, 2 numbers. That's why we have 2 other numbers. So its size is from 1 to 5. So if 1 to 5 are not present, some other numbers are present. Let's say k numbers are different from 1 to 5. K numbers from 1 to 5 are missing. Then those k numbers will be some other value. For example, in -1 and 6 are out of range of 1 to 5. So what is the worst case is that any missing number will be from 1 to n plus 1, where n is the size. As we can see in this case, if we have a size of 5 and all of them are present, then what is the smallest value possible? 6. What is 6? 6 is n plus 1 because n is 5. If this is not the case, as in this case, it will be less than or equal to n. So if we are allowed to use space, what we would do, we would traverse this. So start traversing this list and put them in a set. So 3 is in a set, hash set, so that we can query for it in constant time. Put 2 in set, 1 in set, -1. If it's negative or 0, let's skip it. And we put 6 in the set. So these are in the set. Now we know that any missing number will be from only 1 to n plus 1. And you know the reason why. So we can start a loop for I equal to 1 to n plus 1. And this is set S. So we need to check if S dot find. So if it's not in S, then return I. this ith value was not present, so write not here. If we did not encounter this situation, we will encounter this situation in fact. If not till n, then n plus 1. So we will get this situation sometime. So this should be enough. And searching here in this set, hash set will be O of 1. And this outer loop will take n time. So overall O of n, but this space is O of n as well. So how can we avoid that to meet the second scenario? So we don't need to keep these in set. First thing is that if 1 is missing, this is very simple, you all get it. The second scenario is that 1 is present. Then we check if size is also 1 and 1 is present, then what is the smallest? 2. So this is another base case. If it's more than 1, then start traversing it and go to that index. So let me draw it on separate page. We have, let's take the same example, or let's take this one, 3, 4, minus 1, 1. And 2 also. So its size is 5. So first traverse it, make all the values which are less than or equal to 0 or more than n equal to 1. Now we are handling this scenario, only this branch. So it's confirmed that 1 is present, otherwise we would have returned here itself. So now 1 is present, so any irrelevant value we can make 1. So now what will happen? 2, 3, 4, or let's add a 6 here, make it 6. 2, 3, 6, minus 1, 1. So this is 6, this is 1, this is 1. In fact, this is also 1 because this is more than 5. Now we have size of 5. And one of these numbers are missing from 1 to 6. So what we will do, whatever value we encounter, we go to that index and make that negative if it's positive. So now in this array, we have all the numbers from 1 to n. Because anything greater than n, we had changed to 1. So now it's strictly between 1 to n. And our index is from 0 to n minus 1. So all the values are from 1 to n, all the individual values, and index is from 0 to n. So exactly matching. So let's say we got 2. So we need to shift 1. So if it's 2, then make the index at position 1. 4 is n minus 1. So 2 is there, so go to 2 minus 1. Because if 1 is there, go to first place. So we come here, make it negative. So this is minus 3. The next is 3. So go to index 2, 1 less than this due to this region. Numbers are 1 to n, index is 0 to n minus 1. 3 is there, so come here, make it negative. 1 means 0, make it negative. Then again 1, it's already negative. Again 1, it's already negative. It's already negative. So we stop. This is the output after this transformation. Next, let's come here. So this number was made negative because we had 1. So now we have I equal to 0 to n minus 1. So ith value is negative because there was some value I plus 1 in this list. So negative, fine, negative, fine, fine. The first value is this one, which is positive. That means 0, 1, 2, 3. That means 4 was not present in the original list. So we return 4. So this is the algorithm. So now it will take O of n time and space. Also, we are not using any extra space. We are modifying the input that was given to us. So space is also of 1. So both conditions are satisfied. So let's write the code for this. So first we will check for 1. Contains 1. And once we found 1, we don't need to proceed further. We can break from this. If 1 is missing, return 1. Next, the other scenario. So now when it proceeds beyond this point, it means 1 was present. Now if size is also 1, then return 2. This is a base case. Next, we are doing the transformation. So if it's less than 0, it's of no use to us, or it's greater than n, then also it's of no use to us. Because once we find any number greater than n, then the missing value will be from 1 to n and not beyond that. Because if some value is more than n, that means some value from 1 to n was missing. And in place of that only this number came. So maybe we have already modified this num size, so that will be invalid index. So we are always, this x is acting as an index, one more than index. So this value of x can be from 1 to n, and the indices are from 0 to n minus 1. So we are subtracting 1 here. If it's greater than 0, then make it negative. Or we can multiply by minus 1. And we are done with this transformation. Next, we will just iterate through this vector, and the first index where we find a positive value, we return 1 more than that. Because if that, let's say we find negative at 5th index, that means 6 was not present. Otherwise we would have made it negative here. If 6 was present, if x was 6 in this, then we would have come at 5th index, and whatever value was there, index 5, then we would have made it negative. Else, if none of these scenarios occur, then it's the good case where all the numbers from 1 to n are present. So we return n plus 1. And the solution is accepted. And we are here. You can try a few times, it can go here also. Now we will write it in Java and Python. Not much change is required here. And the Java solution is also accepted, and we are right on top. Next, let's do it in Python. and the Python solution is also accepted, and here also it's good.